to Physical Geology 001A. I am Professor Farida Baksanusa, and today we turn our attention to the dramatic, often destructive but utterly natural movement of Earth's materials downslope, a process geologists call mass wasting. Let's begin with a real story that reveals the sheer force of this process. On a quiet January morning in 1965, 47 million cubic meters of rock and debris broke away from the Johnson Peak in British Columbia, crashing 2,000 meters down the mountain in what became known as the Hope Slide. This catastrophic event, which claimed 4 lives, illustrates mass wasting at its most sudden and devastating. A reminder that Earth's surface is always being reshaped by gravity, often with little warning. So what exactly is mass wasting? At its core, it's the downslope movement of rock, soil or debris driven solely by gravity. No water, wind or glacier required. Mass wasting comes in many forms, from immense rock avalanches to subtle slow soil creep. Some use the term landslide for rapid failures, but mass wasting more broadly captures all movement, fast or slow, large or small. But why do slopes fail? The answer lies in a tug of war between two forces: gravity pulling materials downslope, shear force, and the internal resistance, shear strength of the materials holding them in place. The steeper the slope, the greater the gravitational pull. The stronger the material, thanks to the factors such as rock type, fractures, layering, and internal cohesion, the more likely it can resist movement. But these controls are dynamic. A slope's stability can be radically altered by geologic history, mountain building, glaciation, the type of rock or sediment, and most importantly by the presence of water. Water is a key factor in mass wasting. When present in just the right amount, it can provide cohesion and help particles stick together. But too much water, as after heavy rains, rapid snow melt or poor drainage, fills the gaps, pushes grains apart, and makes the slopes prone to sudden failure. Water can also add weight to a slope, raise water pressure in rocks, and when combined with clay minerals, make materials slippery or weak. Notably, human activity like irrigation, leaking pipes, or changes to surface drainage can unintentionally contribute to dangerous conditions. Most mass wasting events are triggered by a sudden reduction in shear strength. Some common triggers include intense rainfall or rapid snow melt, saturating slopes, earthquakes or volcanic eruptions shaking material loose, freezing and thawing cycles, loosening rock or soil, undercutting slopes by rivers or human activity, example road construction, removal of vegetation which otherwise helps anchor soil. These triggers can tip an already marginally stable slope into sudden catastrophic failure, often without warning. Understanding mass wasting requires sorting events based on the type of material, solid rock, unconsolidated sediment, the mode of movement, fall, slide, flow, the speed from slow creep to rapid avalanches. Falls involve rock or debris dropping through the air. Slides move material as a more or less coherent block along a surface, either flat, translational, or curved, slump, rotational. Flows behave more like a liquid internal motion mixing materials throughout: mud flows, debris flows, lahars. Creep is the imperceptibly slow movement of soil, tipping fence posts and trees over decades. Often real events involve combinations, like a slide that turns into flow, or a fall that creates a debris fan. While we can't prevent mass wasting entirely, there are many tools to minimize its impacts. Engineering solutions: rock bowls, retaining walls, drainage pipes, and catchment basins for debris. Slope monitoring: instruments that detect slight shifts in known danger zones, issuing warnings if conditions change. Good land use planning: avoiding construction on the most vulnerable slopes and careful management of drainage and vegetation. Sometimes, as with avalanche shelters or debris, flow channels along highways infrastructure is designed to let mass wasting happen safely. And in rare cases, entire communities may relocate to stay out of harm's way, as happened in Garibaldi, British Columbia, when analysis showed a future collapse was inevitable. So to wrap up, mass wasting is gravity-driven downslope movement of earth materials ranging from the spectacular to the subtle. Slope stability depends on the balance between gravity and the material's resistance usually affected by slope angle, material type, water content, and internal weaknesses. Triggers are often sudden changes, heavy rain, earthquakes, thaw, or human modification. Classification helps us recognize and respond to different hazards, whether rock falls, slides, flows, or slow creep. While prevention is impossible, thoughtful monitoring, land use planning, and engineering can greatly reduce risk. Understanding mass wasting is not just a geologic exercise, it's essential for protecting people, property, and the landscapes we call home. If you have any doubts, please join my office hours, answer all the questions, and good luck. Bye bye.